So this lesson is on LeChatelier's principle, and we just watched this video from Fuse School. It's about a 4-minute video, so I would suggest you watching this again. If you haven't seen it yet, you should watch it. It's a good little summary on what LeChatelier's principle is. We're going to talk a little bit more about that and make it a little more formalized. Page 564 in your text. LeChatelier's principle says that when a stress is added to a system at equilibrium, so let's just stop and unpack this for a second. A stress can be in many forms. It can be in the form of addition or removal of substance. Okay, an addition or removal of one or more of the substances. What is that? That is a change in concentration. So if we're talking about a stress, one of the ways, and the most common way that we're going to deal with here, is change in concentration. It could also be a change in temperature, or a change in pressure, or the addition of a catalyst, or really any of the other factors that affect reaction rate that we've talked about in earlier lessons, right? So a stress means that the equilibrium is upset. So a stress is added to a system when it is already at equilibrium. What is going to happen? And LeChatelier's principle tells us that the system itself changes, okay? It changes how to counteract the stress. And the goal is to attain a new equilibrium. Okay, you know that in nature, things like to settle down at the state of lowest energy or the lowest conflict. So if a system is at equilibrium, it's forward rate, reverse rate are going at the exact same time, and everybody's happy. It's all fairly static looking, although we know that equilibrium is dynamic. It's always changing, forward, reverse, happening at the same time with no net observable change. When that gets upset, the system, the natural system, whatever it is, the chemical equation between all these products and reactants, it gets upset and it wants to attain a new balance. It wants to attain a new kind of comfortable state. Okay, just like us, right? Just like us as people. If we've got our routine, if we've got everything kind of figured out on where we're going to be and what we're going to do and how we're going to fit this activity in and do our homework and see our friends and do our activities, we got everything figured out, and then something happens, right? You get sick, all right? Or family comes into town, or all of a sudden your activity times have changed, something's been canceled, or you've got an emergency meeting or something, your SRC or whatever it is. Then what happens? You know what you do. You say, okay, wow, now I have to readjust my schedule, right? That's exactly what's happening in the system here, okay? So when something comes into the schedule, it has to readjust. So just think about it that way. So for a system at equilibrium, and just a side note here, annotation note, okay, EQM with a little exponent of a B, okay? Don't ask me where that came from. I learned that in university. I just express equilibrium that way. That's what my prof did, and so that's what I do. So when you see that, that's equilibrium. I'm not going to write out the whole word all the time. But when an equilibrium system, so A plus B is a reversible reaction with C and D, and if more A is added, so here's a representation over here of our system on this little delicate balance. It's at equilibrium. And you can envision it this way. See how the A got bigger? You see that? So what happens is we put in more A here. Okay? And this is one way of looking at it with a little balance like they did in the video. So if more A is produced, this system has to come back to balance. And so what happens is A reacts more with B. It kind of says, hey, I got too much stuff over here. A and B, let's react and produce more C and D so that we can get back to balance. And that's exactly what happens. The A that's added reacts with the B right here. And so A goes down a little bit in concentration after that addition. B goes down a little bit in concentration because this excess A has reacted with some excess with some more B. And then both C and D have increased to attain a new equilibrium. So this is something that you need to think about because there's different reactants and different products involved. Okay? So once again, if we add more A, then A basically says, hey B, I'm in trouble here. We're upset. The balance is upset. Let's you and I get together and quickly produce some more C and D so we can get back to balance. And so they do that. So the A concentration, after you've added, it goes down from its its new high point, it comes down. The B, we didn't add anything to B, so the existing B that was there before, that gets dropped, and then they both produce C and D according to the ratios in the equation. Okay, so that's a little bit of the concentration shift for LeChatelier's principle, and we'll continue that next lesson.